I'm Alexandre from Linea. I will have the pleasure to introduce you to the history of scaling Ethereum and what I have seen in my long journey in the Ethereum ecosystem building rollups. So it all comes down to one problem at the end. Why do we need to solve scalability on Ethereum? Then the problem is Ethereum is secure because everybody verifies everything. When somebody submits a transaction on Ethereum, then the whole network has to verify the transaction. And it means that because of this structure, the capacity of the network is the capacity of the least powerful node. And of course, it causes problem because we want everybody to be able to catch up on the network. And so it was a long known problem. I believe even before Ethereum was created, we knew that on Bitcoin there was this problem and that we could not just push 1 million TPS on Bitcoin and expect it to work. It just wouldn't work. And Ethereum had the same problem, and people already started thinking at solutions to that. So one of the first solution I learned about when I joined the Ethereum ecosystem was about state channel. So the idea is that everything happens off-chain. People sign transfer between each other, and they sign transaction, and then they can exit and just show at once all the trades that they made, and be happy and collectively agree that this is the reality of what happened. There was another idea which was to simply say, well, if the main Ethereum network is not fast enough, then we might as well just do another Ethereum on the side that is more centralized, but send its state to Ethereum so that we can bridge back and forth between Ethereum, and having that would solve the problem. But you lose security by doing that. So it has to be more complicated. So we served up more secure solution like Plasma, where people would peg the state of the rollup on the chain, but there would also be a challenge period to authenticate the state on the rollup. So there would be more security. There would be a way to ensure that what was executed was correct and people can safely exit from the rollup. But that was still not perfect. In particular, there was what we call data availability problem, which is that if the Plasma chain goes down, then you cannot recover the state trustlessly. So basically, everybody just lost their fund. And during that time, the most prominent solution on Ethereum was to add sharding at the Ethereum level. So sharding means that the chain is subdivided in small components called shard. Within a shard, it works exactly like Ethereum, and between shard, transactions are asynchronous. So it works on theory, but that was a really complicated protocol. And we ended up finding a simpler solution to that problem. So it all comes to when rollups and ZK rollups and optimistic rollups were created. If I remember correctly, it was around 2019 that people starting having those ideas to have to improve Plasma and add a data availability layer on it to have optimistic rollups. And at the same time, the community got interested into ZK snarks and snark, which could be used to replace the challenge period by a zero knowledge proof. So it's kind of, and once we had this design, we had a way to scale Ethereum by creating subnetworks called rollups, but having the same security guarantee as Ethereum. And since then, many rollups just popped up, and I believe we have now hundreds of layers 2 that are or rollups that are in inception. And so it was all nice. Like we found a way to have transfers that are scalable, but we want more than transfer. We want smart contract. We want to do like some fancy app. For that, it's a lot more complicated in practice. So still the concept of having a change period still works kind of the same, but we need to make it a little bit more sophisticated to support it. And for zero knowledge proof, it is an order of magnitude more complicated. But at some point, maybe 2 years after rollups were created, people started to ponder the idea that maybe ZK is good enough to do virtual machines such as the Ethereum virtual machine. And if we could have a ZK circuit of the Ethereum virtual machine, or some way to prove execution of the Ethereum virtual machine, then poof, we won. You can have smart contract on rollup. So the only issue was proof systems are really, really costly in terms of computational resource, require a lot of memory. And having, so at the beginning, it was unclear how we would manage to have them. But over the year, we just rapidly improved the speed of the proof systems. And now they are, I would say, two orders of magnitude faster than what they used to be 3 years ago. And this is still going. This is incredible. So, and so now we are there. We have zkVM rollups in production. You can have just smart contracts. You have the same environment as Ethereum, and you have the same security as Ethereum. So now there are still a few trends to follow. One of the things we would like to have better is the finality. On a rollup, normally you have to wait at least several hours or at least half an hour, say, for zk rollups to finalize, and probably weeks for an optimistic rollup to finalize. So that's not great for UX. If you want to exist, then you have to wait, and people don't like that, of course. Second problem is what we call type 1, not being type 1. So as I mentioned, at Linea and other zkVM, we have a circuits to represent the Ethereum virtual machine, but there are some tricks here and there. And the problem is that for smart contracts that are already audited, it is very, very important to have exactly the same environment so that contracts that are already audited can work on the zkVMs. It's also great for client compatibility. It's better if the rollup can support multiple clients. So we want to get there. And another thing that happened is what we call rollup fragmentation. Now that there are many islands of Ethereum ecosystems that exist independently of Ethereum, the user experience has gone worse. Using Ethereum is not as fun as what it used to be years ago before there were rollups. So now there is a big push to to integrate rollup with each other so that people can just do transaction on one smart contract from a rollup to another and have synchronous composition. And finally, since we can do it for rollups, we might as well do it for layer 1. And there is also a big push to add more ZK in Ethereum to make it just more scalable in itself. Right. And so to get there on Linea, we have 3 main things we are working on. So we do not have a zkVM structure, which is a unique feature of Linea. Linea wants to be what we call directly arithmetize EVM, which means proving EVM without layers of emulation. And with this type of technology, we can be 10 times faster, meaning 10 times cheaper proof, meaning 10 times cheaper transactions. We are using lattice-based crypto, which is more efficient, and we are pioneer in this space, in the blockchain space, to use lattice-based crypto to do zero-knowledge proof. And we developed that because we thought it was more efficient, and we finally got benchmarks confirming that, so that's great. Now we need to push it in production. And what we also have is complete EVM equivalent, which is a unique feature for the rollups that have direct arithmetization. All right. That's the end of the talk. So if you have any question, I'd be happy to take some of them. I hope you learned something. Thank you. So 100% proven means that absolutely every step of the EVM is covered by the zero-knowledge proof that protects the execution of the EVM. And that there is no gap, like no tiny smart contracts that are not actually proved or some HKs that are left on the side. Like everything is absolutely covered. And also we have all the features of the EVM as well. Okay. Well, thank you very much.